Now we want to find the order of permutation for disjoint cycles. Based on theorem 4, the order of permutation for disjoint cycle is the least common multiple of the length of each cycle. That means to find the order of permutation for disjoint cycle, we can use the method of least common multiple. For example, we have cycles of 1, 2, 3, and also cycle 4, 5. What order of these two cycles, this joint cycle? So we find it by using least common multiple. This is order 3, that means 3. And this is order 2, that means 2. So least common multiple of 3 and 2. We find the multiple of 3, and then we find the multiple of 2, and we obtain the least multiple with common between 3 and 2. It is 6. So 6 is the order of these two cycles. For number 2, we have order 2 here, and this one 1, 2, 3, 4. I mean, we find least common multiple for 2 and 4. Multiple of 2 is 2, 4, 6, 8, and so on. Multiple of 4 is 4, 8, 12, 16. And the least one, okay, the least common is 4. That means 4 is the order of these two cycles. What about this one? This is actually a joint cycle because we have in this cycle we have 2, in this cycle also we have 2. So we must multiply these two cycle. We multiply these two, we obtain 1 equals to 1. Okay, 1 is mapped to 1 to 1, 1 to 2. Sorry. So we have 1 to 1, 1 to 2, 1 to 2, 2 to 3, 3 is equals to 3, 2 to 3, and then what about 3? 3 to 5, 5 to 5. We have 5 here. And then the last one, 5 to 2, 2 maps to 1. That means we have 2, 3, 5, 1, or 1, 2, 3, 5, which is 1, 2, 3, 4, which is for order 4. For joint cycle, we need to multiply it first and obtain the cycle or disjoint cycle, and then we can obtain the order of this cycle. Next, we proceed with even and odd permutations. From definition of transposition here, it is a cycle of length 2, or we call as 2 cycle. From corollary 1, any permutation of finite set of any least 2 elements is a product of transposition. Let's see example 7. We have this cycle, which is 8 to 6, 6 to 5, 5 to 4, to 3, and to 2, 1, and to 7. In transposition, or to write it in product of transposition, we can write it by write the first cycle with 8 and 7. We take 8 and 7 here, which is 8, 7. The second one, 8 with 1. The third, 8 with 2. Okay, 8 with 2. Next, 8 with 3. 8 with 4. We write all the element in this cycle. 8 with 5. And the last one, 8 with 6. That means we have 1, 2, 3, 4, 5, 6, and 7. That means it is a product of 7 transposition, then we can obtain this cycle. Note that this cycle is order 8. Okay, because we have 8 elements in this cycle. In a symmetric group of degree n for n is greater than 2, the identity permutation is the product of 1, 2 with 1, 2. When we multiply the same the same cycle, that means cycle of 1, 3 multiply with 1, 3, that means it goes to identity permutation. Okay, because we can see here 1 is mapped to 2 right here. 1 is mapped to 2, 2 to 1, so we have 1. 2 to 1, 1 go back to 2, so we have this form. That means this is an identity identity permutation. Number of permutation, okay, based on theorem 5, it can be expressed product of even or odd number of transposition. Okay, that's the number of permutation here. We can express it in even or odd number. If it is in 2, so that means the number of the transposition is an even. If it is 3 or 5 or 7, that means the transposition is odd number. Okay, we can find it clearly in definition 6, which is definition for even and odd permutation. It depends on expressed as a product of even number transposition or product of odd number transposition. Let's consider this example. We have permutation alpha. For number 1, we have 1, 2, 3, 5, and 4. So the product of transposition, to find whether it is even or odd permutation, we must write this permutation in product of transposition first. In product of transposition, we have 1 with 4 here, 1, 4, transposition of 1, 5, 1, 3, and 1, 2. That means we have 1, 2, 3, 4. 4 number of transposition. That means it is an even transposition. For second example, 1, 3, 2, and 4, 5. 1 with 2. Okay, we write transposition 1, 2. 1, 3, transposition of 1, 3, and this is 4, 5. 1, 2, 3. That means 3 number of transposition, which is odd. Next, 1, 3, 2, 4, 5, and also 6, 7, 8. 1, 2, and 1, 3. Okay, we separate into product of transposition. 4, 5, 6 with 8, 6 with 7. So we have 5 number of transposition, which is odd number. So this one, 4. 4, that means it is the transposition of 1, 4 and 1, 4. Because 1 to 4, 4 to 1. 4 to 1, 1 to 4. We obtain 4 here, which is the number of transposition 2. It is an even. The identity element is even transposition.